Hey everyone, welcome back to Workshop Quick Takes. Today on this 2015 Honda Pilot, I have a brake job coming up. If the pads were wearing evenly, they'd only be about halfway down and could probably go another 10, maybe 20,000 miles. But unfortunately, I've got an issue on this side for sure. I haven't looked closely at the left one yet, where maybe one of the floating pins is locking and binding slightly, or possibly one of the calipers, because this is a two-pot caliper up front. Maybe one of the calipers is flexing unevenly, and so the back side has got some uneven wear at an angle, whereas the front is only about half gone. And I also have shimmy in the rotors when I brake, so I gotta do something. As always, when doing a job like this, you want to loosen the bolts on the ground before lifting the vehicle so that you're not trying to turn these off against the parking pawl, which puts a lot of stress on the transmission. Ooh, that one was not quite as tight as it should be. Should double check my torque from last time. As always, come up under a good jacking point, and we have one right here. This tab under the front middle of the engine subframe is a good spot. I now have both front tires far enough off the ground that I should be able to get my jack stands in my favorite place on this vehicle. Here, we pause to note that since this video was filmed, we have switched from using the control arm bushing extension to the bracket bolt through point slightly inboard. The bushing extension is cast aluminum and not designed to carry much weight in normal application, so we figured it probably is not as safe as it looks. Moving the jack another 3 inches inboard is not ideal, but the new point joins the engine subframe to reinforce sections of the unibody and should be much safer. As always, inspect the undercarriage and select a point that is stable and will not interfere with the job you are trying to do. And now we carefully lower it and make sure it settles correctly onto the 2 supports. So what I do next is carefully lower the jack to make sure the jack stands will hold the full weight. Keep the front wheels off the ground, they do. And then I lightly tension the jack back up under the jacking point so that if one of those slips, ideally, weight will transfer to the jack without putting a large dynamic load on the jack, which could blow out a seal. Now that the vehicle is secure, both front wheels are coming off. And since they won't get in the way right here, I'm going to put the wheels down as an emergency catch, just in case. If you always follow a star pattern when removing or attaching the wheels, it equalizes torque on the wheel when you're retightening. So if you do it both tightening and untightening, it becomes a good habit. All right, next up, I'm going to break tradition and use an air impact wrench to loosen the bolts, not to tighten them. This will drive them far too tight. But these are already on a little bit tight from some previous service that was done. So I'm going to remove them with this, and that'll be a little bit gentler than trying to yank at this whole assembly with a breaker bar. Now looking back here, we have 4 bolts that need to come off each side. The first 2 are the brake caliper pin bolts, and these come off with a 17mm. The next 2 will be the actual caliper bracket holder, and those are going to be coming off with a 19. But these 2 first, and then we need to put the caliper up out of the way somewhere where it won't drop. If you've got some spare pieces of solid core copper mains wire kicking around, those work great for this purpose, but if not, something cheap might be more in order. This here is galvanized steel wire sold for electric fences and the like. And a loop of this, doubled over, and then twisted on one end so it doesn't pop apart, is pretty much one of the best things I've found. 17mm, make sure you're set for lefty-loosey. And let's see if these will come off. There's one. Be careful on the second one, depending how loose this actually is, it could just drop. There we go. And we're in there fine for now. This hardware is all still fairly hot because the vehicle was driven not that long ago, so I'm going to switch to a heavier set of gloves. Use whatever gloves you like, but these latex-coated cloth gloves happen to breathe on the back while being very oil and grease impervious on the front, and I happen to like them. Okay, I'm now ready to pull the brake caliper loose, and I have my tie wire ready. Remember, if you let this jerk or flail around, this hose section can actually become damaged internally, and then it'll start to swell under use after that, and then you've got to replace your brake line pretty quick. You can tie off your caliper wherever you like, but personally, I generally like this coil spring on front-wheel drive vehicles. This is a 2-piston caliper or 2-pot caliper, depending on what you want to call it. A lot of front-wheel drive vehicles, especially passenger cars, will only have a single larger pot. This distributes the braking force better on a larger, heavier vehicle like this one. Where you could get into a problem though, is supposing one of these had a bad seal inside and was starting to bind up, then the force would only be applied on one half of the brake pad and it would start to wear unevenly. I don't think that's happening on here. We can get a pliers out in a minute and see if these still move freely. But let's take a look at the brake pads and see what's going on there. Now normally, once you get that off, these come free. And one thing I do see that's missing on here is the little spring retainers. This was previously done by a Toyota dealer right before we bought the vehicle from them used. So it looks like they kind of just slapped stuff together to make sure it had brakes good enough to pass their safety inspection. Here's what concerns me, however. This pad is worn down almost to the point where that little squeal tab, the one that lets you know that your pads are shot, is exposed on this side, but it's a little bit thicker on this side. And meanwhile, this one here is at about half life. One possibility is that the 2 floating pins that we'll look at in a minute might be binding, and so that when it squeezes, it doesn't like just clamp evenly, it like jerks around or something. In any case, these pads are done. Not going to be able to reuse them for anything. Next thing that needs to come out is this caliper retainer bracket. We have to get that out of the way in order to remove the brake rotor. I can't quite get that one right there because the bracket here is in the way of the impact gun. So let me just be 100% clear that using an impact gun with an extension is highly not recommended. And that's what you want to watch out for, and I didn't. Well, there's the caliper retainer bracket. There's 2 things I need to look at on here. First, I'm expecting my brake pad kit to come with replacements for these pieces here. Second, here are the floating pin assemblies. Doesn't feel too bad, but what we can do is pull the floating bolt out of here, clean these out, put some fresh grease in, and then we'll know they're working correctly. Then finally, a nice convenience feature that Honda likes to put on theirs is these little retainer screws here. These have a Phillips head. If somebody's trying to do OE equivalent work, sometimes they'll knock the screw in a little bit just to make sure it can't back itself out, but that's not super important because once the wheel is on, it's not going anywhere anyway. Just try and turn them off by hand, and if they come, great. If they don't, sometimes you just need to knock the back of the screwdriver with a hammer a couple times to shake them up, and then they'll turn loose. Last step now is to pull the rotor. If it won't come off cleanly, there are a couple screw holes here. Let's just see right now if this rotor is already loose. And it is. Next step in our journey here is the unboxing of the replacement rotor. If you happen to know a good machine shop, sometimes you can get a rotor remilled. Increasingly few people seem to do that anymore, and it also requires a second vehicle because obviously the one you're working on is out of service. So sometimes, for about 3 times the price of milling an existing rotor, you can often buy a basic replacement. And so that's what I've chosen to do today. They look fine to me. Everything's nice and clean and shiny as it should be. This here, if I could find somebody to remill it, would probably be good. Still got a fairly even amount of thickness front and rear, so nothing looking too bad there. But like I said, it does shimmy when we brake, which means it's warped a little bit. Now when you buy replacement rotors, they'll usually come with a thin film of kind of an oily, greasy compound that prevents them from rusting during shipment. So make sure to just use brake cleaner or something similar that pulls grease. That brownish film on there, that's the compound that got pulled off. And then the other side as well. These do have some kind of nice coating on here that should slow down the rusting of the top hat section, so that's nice. Now this hub assembly recently had to be replaced due to a bad wheel bearing, so if you're doing this on a 100,000 plus mile vehicle, don't expect it to look all clean and shiny like this. But what really matters at this point is we have a screw hole here and a screw hole here, which is where our Phillips go back into. We want to line this rotor up so that these countersunk holes line up. And there we go. Here's our brake pad kit. Usually I just go for whatever the mid-grade ceramic option is. And I did go ahead and buy some of the lubricant just so I can apply that and hopefully keep things from shrieking too much. Here we go. Okay, so there are 4 of these metal tabs in here, and there should be 4 of the little springs that tension the brake pads. We'll be putting those on last. It's generally a good idea to replace these if you can, because especially on older vehicles, you can sometimes get a lot of rust in here. These should just pop off like that. Now, generally they don't have an orientation. You just put one back in every single spot, but just to make sure, I pulled this one off like that, and I'll put this one on like this. And if all is going well, that's usually all you should need to do other than putting a little lube in here. Brake pads. Now normally when you buy a kit, you get 4, so it covers both sides. Notice this one here does not have the squeal tab, so this one's going to go on the front side of the rotor. This one here also does not have the squeal tab, so this is going to go on the front side of the other rotor. This one here does, and if you'll notice, it overlaps the edge so that if the brake pad wears past that point, that starts dragging on the disc, makes a frightful shrieking noise, and lets you know that you should be looking into new brakes. And if everything went well, we should have one more with the squeal tab. Perfect. So these two will be for the front left that we haven't taken apart yet. These here, we're going to go ahead and put on the front right after we finish working on our caliper bracket over here. The floating pins actually have these boots over them, but the boots pop off. And if you happen to extract one of these and notice that the boot is torn, you need to get a replacement. You can generally buy a replacement hardware kit at the auto parts store and put the new one on. But there's what we're looking at. Sometimes only the top or only the bottom has this little nylon or plastic pin on it, and I'm not sure exactly why or what that does. So we know that one was there. Let's take a look at the top one and see if it's identical or if it's just a blank. It's just a blank. Putting them back in the same order should help ensure that everything works the way it's supposed to. I'm going to do these one at a time to make sure I get them back into the same order, but I'm going to take a little brake parts cleaner and just get the old grease off that pin. And do the same thing with the inside here. Okay, now I'm going to take a little bit of grease from this tub, and I'm just going to recoat this pin. You can use a decent amount, but you don't want to actually overfill one of these chambers in here, because if you do, you'll actually start to get pressure pushing back out. That there should be plenty. Yeah, I've already got too much. There's a problem. Let me thin this off slightly with WD-40. See if that goes in now. There we go. That's what I was looking for, and I want to see the boot reseal. Okay. That's a little stiff right now, but when it's at a high temperature operation, it should settle in nicely. I imagine there's probably a specific recommended grease provided for these kinds of parts. All I know is I've been doing it this way for years, and it seems to improve them. Again, just a small amount of grease on the pin. Spritz with WD-40 to thin it slightly. Okay, that one went really nice and clean. Well, the neighbor over there is making a valiant attempt to mow the lawn with an old unmuffled 2-stroke mower, and I don't think it's going so well. We now need to get these back on. These do fit on from behind, and in this case they do have a nice machine little lip here to make sure that you can line them up, which I like. Now remember, we are now reassembling. I am not going to use the pneumatic gun to reassemble because I'm not trying to blow these bolts right out of the hub carrier here. However, it is important that these go on with the correct amount of torque. I don't know what that is, so I'm going to wing it. But I am using a awfully big breaker bar here, so I'm pretty sure we'll get it close. Main clue is that we're using a large diameter bolt into a fairly big casting, so. Again, note the order of operations, because if you don't, you'll be taking stuff apart. Disc rotor goes on first, then this carrier. I think he needs to rebuild that carburetor. Okay, so next up here, we're taking just a very small amount of this grease and getting it inside these slides. Remember, we're not trying to frost a cake here. We just want a little bit of a friction reduction in the area where the pads are supposed to go back and forth here. We need to get these pistons retracted a bit because our new brake pad is going to be thicker, and this just won't slide back on if we don't. So, a couple ways to do that. Some people use like a screw press clamp. I'm going to try and do it just with the channel locks. What I'm kind of expecting to happen though is as I squeeze one side down, I'm betting the other one pops up. Yep. So let's collapse that one all the way, see if it stays partway down, and if it doesn't, we'll get another channel locks and do this two-handed. What we're really trying to do here is force the fluid back up into the brake fluid reservoir rather than the opposite piston. If you're doing this with a single piston caliper, then this won't be a problem. Both of these are moving fairly freely, which is a good sign. But that there hopefully gives us enough room. Next up, we need our two brake pads. This one fits right up here, or should. It's kind of a little weird. You got to work it in there underneath the caliper bracket. And then this one here, which has a squeal tab, goes like this. And notice how the curved side follows the curve of the rotor, so that tells you which way it goes in. There we go. Next step here, which that previous shop missed, is these tensioner springs. And there's a couple little pre-drilled holes. So the top one's going to go up like this, and the bottom one like this. And these just help put a little bit of tension on the pads so that they don't bind up as easily. It will technically work without them, but they're included with the kit and you're supposed to install them. Last step then is to get a rotor put back on. Again, I don't want to drop this, so I'm just going to rest it right there while I finish undoing my wire. Save this for the other side, I'll use it again. And now we need to work this over the pads and see if we actually compress the rotors enough to do that. Oh, not quite. It's still a little tight. I got to get these all the way down. One thing you do got to watch out for when changing pads, especially if you had a really worn set of pads for a long time and had to top off the brake fluid reservoir, you press these in, you might actually drive enough brake fluid back into the reservoir to squirt it out the top. So pay attention to that before you wrap up the job. Okay. That there is as collapsed as they're getting, so hopefully they fit now. Okay, good. Now, one more thing to watch out for on these caliper floating pins. Currently, I do not have that rotated correctly, and the way I know is that this tab right there is supposed to be a locking mechanism. So I need to rotate this, make sure this doesn't fall out of my leg either, that would hurt, until it's roughly like right there, and now it'll lock into place as I'm sinking the bolt. Down here, you need to look for the exact same thing, and this one's actually close to the right position, but it does there. Okay, now I should be able to put the bolts in, and we're good to go on this side. Again, remember the caliper bracket bolts were 19s and the caliper retention bolts are 17s. Now these 17s here on this vehicle can take a decent amount of torque. I don't want as much as I put on the caliper retention bracket. One thing you want to watch out for on other Hondas though, especially like older CR-Vs and Civics, is these bolts in my opinion are way too small and they do stretch on those vehicles. If it feels like you're having trouble getting torqued, stop, go buy a replacement pair of bolts. You will definitely regret it if one of those works its way back out on the highway. Okay, that there feels good. And that there feels good. One side ready to go, just need to do the other. It's the exact same procedure, just facing the other direction.
On this vehicle, both front brake calipers face forward, which means the layout of things like the softline hose and the ABS wheel speed sensor are also flipped. But other than trying to remember what righty-tighty and lefty-loosey mean in mirror image, the job is pretty much the same. Remove the brake caliper and tie it up to the spring to protect the caliper and softline. Then, remove the caliper holder bracket with the old pads. Remove the old rotor.
In case you've never had to do this before, that's why these two extra holes are here.
Clean and install the new rotor. Install the slider clips and clean the floating pin assemblies on the caliper holder bracket. Finally, reinstall the caliper holder bracket, followed by the caliper after once again compressing the pistons for clearance. Seems straightforward, but sometimes when you speak your enemy's name, he appears. We were in the final stages of reassembling the caliper to the pin bolts and discovered that something on the upper mount didn't feel quite right.
Okay, oh boy. Well, there's what we were worried about. Actually stretched a bolt out, so need to go get that replaced before we finish this job.
Sometimes shop stock is what you got. We had class 10.9 bolts in the correct thread, but a bit too long, and oddly enough they had a smaller head. After realizing a bandsaw wasn't the right tool, we switched to a cutoff wheel, then finished the end with a bench grinder. It worked, but that smaller bolt head weighed on our conscience a bit.
I had to hit two different auto parts stores in order to get two kits, but essentially you buy the whole floating pin and bolt assembly In this case, I think my floating pins are probably fine. So I'm going to go ahead and just leave those in there. But I'm at a point right now where it's still very easy to pull the bolts out and replace them with these. So that's what I'm going to do. Now my first thought was, it's an M10 by 1.5 bolt, so why not just take another standard metric class 10.9 bolt, like for like, and cut it down? Well, that was a great idea until I got to looking at it real closely. Note the difference in the flange size on the head, as well as the fact that this one's a 17 and that's probably like a 14 or something. Well, that extra surface area right here is part of the friction fit that this bolt obtains once it's torqued down. So if you try and use something smaller, it may not actually be as tight as it should be to resist working its way back out. Might work for a while, might cause some brake failure on the road. Not worth taking the chance. Now as for why this happens, I mean, I may have over-tightened them at some point, but I feel like all four of these have been stretching while I've been working on them, so I'm just going to replace them. And I do know that when I took them off for the first time on that side a couple weeks ago, and now today when I took them off this side for the first time, they felt a little bit tight. And this was last worked on at a Toyota dealership, probably an ASE certified mechanic. No offense to those of you who are ASE certified, but I've encountered a couple techs who thought that ASE meant always stretch every bolt. And as a result, I've had things break. I feel like too many mechanics, even if they've had training, they get their hands on one of these and they start pointing it around at everything like a 5-year-old that just discovered water pistols. And you always over torque bolts with these if you're not setting them correctly. Okay, so here's our replacement bolt. It is still a 17. We're going to replace this one first, but not torque it down. Then I'm going to pull the factory one over here and replace that one. Next, I'll go to the other side, do the same thing again, and hopefully these brakes won't fail on us when we're driving down to Colorado Springs next week. Yeah, I'm looking at that, and I'm seeing this one stretch a little bit too. There's like a narrower, slightly narrower spot, I think. Right there at the base of the threads, about the same place where the other one broke. It's what happens. So let that be a lesson. If you're working on a bolt in a critical location and it feels like it's just not torquing down the way you'd expect it to, trust that instinct, just replace it. And that is nice and set. That one there still looks pretty good, but nonetheless, we have the replacement, so we'll be chucking this one. Not really seeing anything obvious on that one either, but again, new replacement. Okay, that feels like a proper torque. As does that. Now, if you don't know Ryobi's tool line, this impact gun is only good for somewhere between maybe 50 and 75 pounds. Driving in a set of wheel lugs with it is fine. They need to be torqued to about 95, I think it is, and this gun won't do it, and it certainly won't exceed it. When you start the vehicle for the first time after manually compressing the calipers like that, you don't want to just stomp the pedal because you're going to be pushing a whole bunch of fluid into the pistons and you don't want to just blam that all out at once. You want to do it softly and gently a few times, about 3, 4, 5 pumps until you feel everything firm up. So 1, 2, and it's still giving quite a bit. Okay, it's giving less. Okay, we got a nice firm brake pedal. That's the job done. Now it's just time to take it for a test drive. We'll get a quick discussion on why you need to let brakes bed in. What is it and what does it do for you? Okay, second thing that should be on your mind as you exit your garage or other workspace is don't go flying out of it, because if you brake and nothing happens, that's a bad day. But so far, we're doing pretty good. The next thing I like to do in order to make sure everything is going well is find a loop, a back road loop, where I can speed up and slow down a bit without inconveniencing any other traffic. And then I'll do a few things like accelerate mildly while also braking mildly. Again, the idea isn't to lock up the pads here, it's just to drag some friction on them, and what I'm trying to do is bed in the brakes. One possible misconception some people have about brakes is the friction between the brake pad and the metal disc is what slows you down, but in fact, some of the brake material is constantly being deposited into the surface of the metal rotor, and that's called bedding in. And so then when you go to actually hit the brakes, the friction that occurs is between the brake material on the brake pad and the thin layer of brake material that is on the surface of the rotor. But the brakes need to bed in a little bit before that happens, and until they do, they won't work quite as well. And he's still back there, so I'm going to turn on a side street here. Everything's still slowing down nicely, and I no longer have that shimmy that I had before on the old warped rotor, so that's good. Okay, I discovered some interesting e-throttle behavior I did not know existed on this vehicle. If I press the accelerator and the brake at the same time, the accelerator disengages. It's a smart feature, but it doesn't allow me to do what I like to do, which was to actually brake under powered load, and that kind of, gave the brakes a little workout. So the idea is not to just brake with all your might, but just kind of a gentle friction that allows the vehicle to scrub on the pads pretty good, but without trying to just grind them up or set them on fire type of thing. So lots of speeding up and slowing down, but keeping it fairly gentle at first. All right, now we've got a long stretch here. It's straight, there's no driveways, speed limit's 50, so I can get going a bit faster here, and then try a long, hard stop. And if it doesn't work for some reason, I've got plenty of room to coast back down. Nobody behind me, nobody in front. They're not quite there yet. I can feel the pedal having to go down a little farther than normal to actually slow down. Partly that's characteristic of ceramic brake pads, and partly it just improves as they bed into the rotor. But for now, everything seems to be working, so I think we've gotten the job done. Okay, I went ahead and ran that loop twice. On the second time around, I noticed that the braking performance was getting noticeably better. You can kind of see it by looking at the rotor. Let's just take a look. Over the crosshatch that was on the rotor, you're starting to see those circular marks. That's some of the brake pad material starting to maintain a thin film on the surface of the steel rotor. The bedding in process is actually maintained naturally by the brakes simply dragging gently on the disc at all times, and that helps keep that layer maintained on the surface. So there you have it. Should be a fairly straightforward job, but if you get into issues like those caliper bolts stretching, which can happen, or you have to pull and re-grease the caliper floating pins, it may take a little longer. Them's the risks, and if you're willing to do it, you can save a few bucks and just pay for the parts and put in your own time. So, thanks for joining me again on Workshop Quick Takes. See you next time, whenever that is.
Has anyone seen my phone?